Hi, this is Dr. Jenkins. Today we're going to be talking about blood typing. All right, this is the same PowerPoint that's available to you on Blackboard. With blood typing, the first place to start would be some basic definitions. As you can see, I got my trusty little meter stick here. First, define antigen. An antigen is a large protein on the cell surface, and it's normal. So a blood type A person, for example, naturally has A antigens on their red blood cell surface. They're normal, the body perceives them as normal, everything's okay. A B blood type person has B antigens on their red blood cell surface, okay? So an antigen is a large protein on the cell surface, and it is considered normal by the body. Either it's there or it's not, no big deal. Whereas an antibody is something that our body produces in response to exposure to an antigen. Let's say, for example, as a kid you had chicken pox. Well, your body produced antibodies to protect you against that chicken pox. So we produce antibodies to protect against something. We'll talk about this later in a minute here, but in the case of blood typing, we produce antibodies to protect against antigens we don't have. That'll make more sense in a little bit, but I would start with these basic definitions. Antigens, a normal protein on the red blood cell surface. Either you have it or you don't. An antibody is something that we produce in response to exposure to something. And as you can see here, the antibodies are located in the blood plasma, not just on the red blood cell surface. Okay, moving on, if we look at the blood typing, they're based off of the antigens. So an A blood type person has an A antigen on the red blood cell surface. A B blood type person naturally has B antigens on their red blood cell surface. An AB blood person has both A and B antigens on their red blood cell surface. Whereas an O blood person has neither. They don't have A or B antigens. I'm going to skip ahead to talk about blood typing to a slide that has a nice visual. Blood typing can be a little confusing at first. So if it's confusing at first, or you get it, but then you go home and look at it later and it's still confusing, you're not alone. So just keep looking at it, keep going over the main points, and eventually you will get it. So let's look at this visually. We can see that the type A blood person, as we already said, the blood type is named off of what antigens you have. So a type A blood person naturally has A antigens on their red blood cell surface. In this case, the A antigens are denoted by the red circles. Likewise, a type B blood person has B antigens on their red blood cell surface. In this case, they're blue triangles. A type AB blood type has both A and B antigens. A type O blood type has neither. They don't have A or B. What I like this visual for is looking at the antibodies. So remember, an antibody is a protein in the blood plasma, and we produce an antibody in response to something that we're exposed to. In this case, we produce antibodies to protect against the antigen we don't have. Let me say that again. We produce antibodies to protect against the antigen that we don't have, because the antigen that we don't have is viewed as foreign by our body. Let's give them some examples. The A blood type, we know they have the A antigen on their red blood cell surface. Well, the A blood type person is going to produce antibodies to protect against the antigen they don't have. An A blood type has the A antigen but not the B antigen. So they will produce antibodies to protect against the B. So a type A blood person has the A antigen, but the anti-B antibodies in their plasma. Another way of looking at that is just reverse. So if you have the A antigen, you have the anti-B antibody. Let's now look at a type B blood type. A type B blood type has the B antigen, but they have the anti-A antibodies. Okay? AB has both antigens, so they don't have to have any antibodies. If the goal of the antibody is to protect against what you don't have, the AB blood person has both antigens. So they don't have to protect against what they don't have because they have both. Whereas the type O blood person has neither antigen, so they've got to produce antibodies against both A and B. So the type O blood person has no antigens, but has both the anti-A and anti-B antibodies. Take some time with this, you're gonna get it, all right? Let's look at what happens if we mix two blood types that shouldn't be mixed, okay? Before I do that, well actually I'll wait for that. Let me first go through this. Let's look at what would happen if we mix a type B blood person with a type A. What's gonna happen is something called agglutination or clumping. And that's gonna be where an antibody attaches to a matching antigen, and that antibody will break down the cell, and the red blood cells will hemolyze, basically blow up or just decompose into nothing. Really not a good situation. Let's look more detailed, okay? Type B. We know the type B blood type has the B antigen on the red blood cell surface and the anti-A antibody. Type A has the A antigen and the anti-B antibody. If we mix them, what's going to happen is the antibody from one blood type will attach to the matching antigen on the other. So you may know this already, but antibodies can only attach and work on things that it matches. So for the chickenpox example I gave, the only antibody that can work against the chickenpox is a chickenpox antibody. In this case, the anti-B antibody is only going to be able to fit into a B antigen. The anti-B antibody can only fit into the B antigen. An anti-A antibody can only fit into an A antigen. So when you mix blood types, now we have a matching antibody to antigen. So in this case, the anti-B antibody from type A blood will attach to its matching B antigen on the B blood type. When we have a matching antibody to antigen complex, the antibody works to break down the cell. In this case, we don't want that. Agglutination, clumping, and then the cells will hemolyze and basically die. Last thing for this video is I want to go back and talk about the universal donor and universal recipient. Okay? Type AB is the universal recipient. A person that has type AB blood can receive blood from anybody. Type O is the universal donor. O blood can be given to anybody. The way that I remember type O being the universal donor is that the word universal donor has an O in it. So donor, that second O, donor, type O is the universal donor. There's a couple slides here that explain how that works. This will be our last topic. Let me go ahead. Boom. How can the AB blood type be the universal recipient? Well, let's look at it. AB blood can receive blood from anybody, universal recipient. What if we give type A blood to type AB? Indeed, some of the anti-B antibodies, some of the anti-B antibodies from the A blood type will bind to the B antigens on the AB blood type. However, it's not going to be enough of a reaction to cause an overall problem. We have plenty of A antigens that are not going to be affected. So there might be some binding of the anti-B to the B antigen in this case, but it's not going to be an overall problem. Let's look at why can O be the universal donor? So type O blood can be given or donated to anyone. How does that work? Here's the blood type O, What if we donate blood type O to type A? Well, we have some anti-A and anti-B antibodies. Let me go this way. Hold on. Type A has some anti-B antibodies. But let's say these anti-B antibodies want to try to attach to an antigen. There's none to attach to. So type O is a universal donor because even if this one has some antibodies, there's nothing for it attached to. So there's no agglutination. All right, get the definitions first, and then the blood typing. You're going to be good as gold. Good luck.